Hello students, so here is the corrections for assignment 1B. Let's get started. So the first question, you're supposed to find the prime factorization of square root 2916. So what do? Well, first thing we do is to perform prime factorization on 2916. So by doing it systematically, you should obtain 2 to the power of 2 times 3 to the power of 6 and realize that that is actually 2 times 3 to the power of 3 bracket square. So this is what you need to have, and then when you square root it, remember that it is a reverse process of the square. So square root of 2916 gives us 2 times 3 to the power of 3, which is 54. One additional thing to take note when we are dealing with questions such as this, where we are trying to find either the square root of the cube root using the prime factorization method, is to take extra care with the way we handle our equal sign, because a common mistake by some students is to actually mistakenly write the equal sign and saying that 2916 is actually equals to the square root of 2916. So you got to be careful, and there are actually two distinct parts to the working. So here's another question. Given that the prime factorization of each of the following numbers, find the square root without using a calculator. So what we are doing, once again, we are trying to find the square root of this number, a pretty huge number, 24,336. So in the same way, right, we need to figure out that 24,336 is actually 2 to the power of 4 times 3 to the power of 2 times 13 squared. We can actually reduce it to 2 to the power of 2 times 3 times 13, and the entire portion here square. So this is the first part of the working. In the second part, when we try to square root it, that's where we actually just take the bracket portion, and we will have 2 squared times 3 times 13, which gives us 156. Now moving on to a few practice using the cube root. So cube root of 5,832. So 5,832 is 2 to the power of 3 times 3 to the power of 6. So in the same way, we can actually write it in the form of 2 times 3 squared, the entire portion there, cube, right? So the cube root, again, the second part of the working, the cube root, now we actually just take the bracket portion, 2 times 3 squared, which gives us 18. Another practice, this time round a much larger number, 1,728,000. So that gives us 2 to the power 9 times 3 to the power 3 times 5 to the power 3. That works out to 2 to the power 3 times 3 times 5, the bracket, cube. So when we cube root it, we just take the bracket portion. That will be 2 to the power 3 times 3 times 5 equals to 120. So these questions are generally not very complicated, and I expect most students to be able to handle it. The only thing that you got to be really careful is the way you present your solution, because if you don't present it in the right manner and you actually put your equal sign in the wrong position, that will result in your solution being incorrect. Right, so here's another question, a different kind. This time round is actually to practice using the calculator to evaluate square root and cube root. So nothing too complicated here, just use your calculator carefully. You will get 1.002436,942. That's the entire string that is displayed on your calculator. The question wants us to write it in 4 decimal places. So that will be equals to 1.0024. Now, definitely good habit to at the end of 1.0024 to indicate 4 dp, which represent 4 decimal places, so that it is clear that this is actually rounded off. Without telling people that it is 4 dp here, this solution is technically incorrect, because they are not equal, right? Quite obvious. 1.002436,942 is not equals to 1.0024. Hence, indicating 4 decimal places here is actually quite crucial if you want to be really mathematically correct. Right, next one. Find the smallest non-zero whole numbers which can be multiplied by 112 to give a square number. So what we can do here, once again, is to make use of the idea, okay, that the power or the index of the prime factorization of a number, if they are even, then we get a square number. So here we go. We know that 112 is actually 2 to the power of 4 times 7. Therefore, a square number, which is a multiple of 112, will be 2 to the power of 4 times 7 squared, because we want the power to be even. Therefore, what we need is an additional multiplying it by 7. So that's the solution. Now, the second part of the question, this time round, we want a cube. So a perfect cube is where the index or the power is to the power of 3. So what we want is 2 to the power of 6 times 7 to the power of 3. So what is missing is actually 2 to the power of 2 and 7 to the power of 2. So we put them together, we'll get 196. Right, here's an interesting question, right? A textbook is open at random without using a calculator. Find the pages of the textbook is open to, given that the product of the facing page is 420. So what's happening is we know if the two pages, they must be one number after the other, right? So with what if the one of the page is page n, the other page will be n plus 1. So we know that n times n plus 1 is 420. That means n squared plus n is actually 420 if we expand it properly. So we know that n squared is a perfect square, right? So the perfect square that is nearest to 420 is actually 400. So we work that out, we realize that n is actually 20. Therefore, the pages are 20 and 21. Okay, one more question. Raju has 2021 centimeter square tiles. He made the largest square tile possible using some of the 2020 square tiles. How many square tiles does he have left over? So this question, what happened is when we try to square root 2020, we get 44.9444. Of course, the nearest value will actually be 45, but we can't use 45 because that will end up needing more than 2020 tiles. So the largest square tile we can actually create is actually 44 tiles by 44 tiles. So the number of tiles left over will be 2020 minus 44 square as 84. Alright, hope you have been successful. Have a nice day.